To find the derivative of number 4 using first principles, I've set it up here in the proper form where you're taking the gamma function at x plus h and minusing it at x, and then dividing it all by h with the limit as h approaching 0. So that goes back to the first principles, or the definition of the derivative. So I've given you the first few steps here just to kind of flesh it out and get it down into a form that you can work with. When you get to this step, then we need to find something for t to the h minus 1. And we also have this bothersome 1 over h here that as h approaches 0 is going to give us an undefined value still. So if we combine those two, and we look at it as a limit as h approaches 0 of t to the h minus 1, and that's not a part of the exponent there, that's minus 1, over h, then that you will find in your textbook or online as a definition from when we were finding the limit of exponential functions. So a general exponential function is a to the x minus 1 over x, and that has a limit as x approaches 0 of the ln of a. So using the same sort of intuition there, we can go back and we can then apply that to this, which will replace the 1 over h, t to the h minus 1, with ln of t. So that's going to get us to the derivative of the function that we were being asked to find there. And I think that should answer the question if he's looking for first principles, which apparently he is.